To Dynamics Part 1, Newton's second law. And as you see in the screen, Newton's second law is F equals ma, where F is the force applied, m is the mass of the body, and a is the acceleration of the body. Something to keep in mind, force is a vector as acceleration is. Because of the way we normally work in the workaday world, we normally use the scalar form of the equation, which is just F equals ma again. It's just that we leave off the arrows on the vector components. Now, a force is a push or a pull. That's it. And as long as a force is acting on a body, the body accelerates. Once the force stops, the acceleration stops. An example would be if you're throwing a ball, as long as your arm is moving forward and the ball is in your hand and you're exerting a force on it, the ball is accelerating. The moment the ball leaves your hand, the force stops and the object, or in this case the ball, stops accelerating. Now the units of force are newtons, given the symbol N, and 1 newton is nothing more than 1 kilogram meter per second squared. The mass, and here's the acceleration. Okay, we're going to try a very simple example here. Example number 1. A bowler pushes a 5 kilogram ball with an acceleration of 2.5 meters per second square. Find the force. Well, it's just F equals ma. The force is equal to the mass, 5.0 kilograms, times the acceleration, 2.5 meters per second squared. Give myself a little room to write here. Force is 12.5 kilogram meters per second squared. That is a newton, so we have 12.5 newtons. Straightforward, nothing magical about that. Now, there is a special force, and it's called weight. And it's nothing more than the force of gravity. And when you're on the Earth, force of gravity always acts towards the center of the Earth. So, force is equal to ma. In this particular case, we're talking about specifically weight. So you need the mass of the body. And the acceleration is g, the acceleration due to gravity. Example number 2. Find the weight of a 2 kilogram mass. Weight is equal to mg. The weight of the body is 2.0 kilograms times 9.8 meters per second squared. So the weight of the body is 19.6 kilogram meters per second squared. Again, definition of a newton, so the weight of the body is 19.6 newtons. Again, this is the weight of the body. That's how hard the Earth is pulling it downward. 2 kilograms is the mass of the body. Mass measures how much material is present. It doesn't change no matter where you are in the universe. Weight changes or varies depending on what planet you're on. Okay, example number 3. What force is needed to accelerate a car at minus 5.0 meters per second square if the car has a mass of 1,000 kilograms. All right. Accelerating in a negative acceleration is called deceleration or slowing. Go to the standby, F equals ma. The force is equal to the mass, 1,000 kilograms. times minus 5.0 meters per second squared. And we get a force of minus 5,000 newtons. The minus sign indicates that the force is applied in a direction opposite to the motion of the car. This is a braking force. And this is where the idea of the vector, a force being a vector, comes into play. It's acting in the opposite direction of motion. Okay, I hope this helped. Please feel free to leave a comment, more examples, things weren't clear, anything that you think will make this a better presentation. Thanks for your time.